Now I'm going to explain to you the definition of a diameter of an ellipse, but before that let me prove these properties of an ellipse. That is, the locus of the middle points of system parallel chord is a straight line passing through the center of the ellipse. X square by a square plus y square by b square is equal to 1. So you draw this ellipse and then take the system of parallel chord represented by black line here. So these are all parallel to one another and they are the chords of an ellipse. Now I need to show that the line which passes through the midpoints of all the system of parallel chord will be nothing but a straight line which passes through the center of the ellipse. That means represented by this one. So this is a straight line represented by which passes through the center of the ellipse, that is passing through the origin. So to prove this one, let us first take M to be the slope of the system of parallel chord. So if I take M to be the slope of a system of parallel chord, and then next take x1, y1 to be the midpoint of one of the system of parallel chord. So without loss of generality, I can take x1, y1 to be the midpoint of the second chord, that is this one. And we know that the equation, in the earlier classes I have given you the explanation on the equation of the chord in terms of its middle point. So if the middle point is x1, y1, then what will be the equation of that chord? For in particular, it will be this chord, second chord here, will be given by the formula x1 by a square plus y1 by b square is equal to x1 square by a square plus y1 square by b square. So this is the formula for the equation of the chord in terms of its midpoint x1, y1. Now from this equation of the chord in terms of its middle point, we can express this equation now in terms of in the form of y is equal to mx plus c. Transfer the terms to that side and express it in the form y is equal to mx plus c. Now from here you see that this one will represent the slope of the chord. Slope of the chord, that means this one, okay. But we know that in the beginning I've taken M to be the slope of the system of parallel chord. That means M is the slope of each one of this parallel chord here. So in that case you'll get M is equal to minus b square by a square x1 by y1. So this is a slope of this line. Now let us simplify this one. We'll get y1 will be equal to minus b square by a square m into x1. Now we have the expression of y1 as minus b square by a square m into x1. Now since this x1, y1 is a point in this equation, point in this line, midpoint of this second chord, then it satisfies the equation. So this one will satisfy, and also x1, y1 is not the fixed point. It can be a point at the midpoint of the first chord, or it can be the midpoint of the third chord, midpoint of the fourth chord, and so on. It is a moving point only. So therefore the locus, now the locus or the path traces by x1, y1 will be given by, you replace y1 by y and x by, will be y is equal to minus b square by a square m into x. Or it can be written as y is equal to mx or m1x, where m1 here is minus b square by a square m. So now you see that the path traces by this midpoint x1, y1 will be given by y is equal to minus b square by a square m into x. Or y can be written as m1x, where m1 is equal to minus b square by a square m. But now we know that this equation represents nothing but a straight line passing through the origin. So therefore, this line, the line which passes through this midpoint x1, y1 will be nothing but it is a straight line which passes through the origin, because equation of the line which passes through the origin will be the form y is equal to mx. If there is a constant c, then in that case it will not be a straight line passing through the origin. But if the constant term is absent, just y is equal to mx, then it always represents a straight line which passes through the origin. So in this case, this path traces by the midpoints x1, y1 of the system of parallel chord will be nothing but it will be a straight line passing through the origin, represented by y is equal to m1x, where m1 is equal to minus b square by a square m. So this proved the result that the locus of the middle point or the path traces by the middle points of system of parallel chord will be a straight line passing through the center of the ellipse. Now, let us come to the definition of diameter. Definition of diameter is defined in this way. It is a locus of the middle points of the system of parallel chords of the ellipse. X square by a square plus y square by b square is equal to 1. And this will be called the diameter. So, from this discussion, we conclude that this line which passes through the origin or the path traces by the midpoints of the system of parallel chord will be nothing but will be a diameter. So now here you draw the ellipse and then draw the system of parallel chord. Now take the midpoint of this one to be this one, the second one to be here, third one, and so on. Then when you join these midpoints of the system of parallel chord, you'll get a straight line which passes through the origin, and then this straight line will be called as the diameter of the ellipse. So the diameter of the ellipse will be this one, a straight line which passes through the midpoints of the system of parallel chord, and it is given by the equation y is equal to minus b square by a square m into x from the earlier discussion. Okay, so we have the expression of y is equal to minus b square by a square m into x, where m here represents the slope of the system of parallel chord. Now, what do you mean by conjugate diameters? Two diameters are said to be conjugate diameters of an ellipse if each bisect the chord parallel to the other. Now, this is the diameter. Now, what will be the diameter which is conjugate to this one? So, what you need to do is now you draw a system of parallel chord which is parallel to this diameter. Now, if you take the midpoint of this system of parallel chord, including the midpoint of the diameter, then you'll get another straight line which passes through the origin. And this will be called as the conjugate diameters. Now, the diameter is nothing but it is a line which passes through the origin and passes through the midpoints of the system of parallel chord. Now, next what you need to do is draw another system of parallel chord, now parallel to the diameter. Now, on drawing the system of parallel chord which is parallel to the diameter, represented by this blue colored line, then next step what you need to do, again take the midpoint of the system of parallel chord of this blue line including the diameter, and then when you join them you'll get this straight line which again passes through the origin, and this one now will be called as the conjugate diameter of this given diameter here. So that is the definition of conjugate diameter. Now next, let me come to this one. The next property of the diameter. The tangent to an ellipse at either extremity of the diameter is parallel to the system of chords bisected by the diameter. Now what do you mean by this one? First you draw the ellipse and then take the system of parallel chord represented by this black colored line here. Now next, we know that a line which passes through the midpoints of the system of parallel chord will be a diameter. And then what we need to show now according to this property is that if you draw a tangent at one of the extremity, at either this extremity here or at this one, then that tangent will be parallel to the system of parallel chord bisected by the diameter. That means you need to show that the slope of this tangent here will be the same as the slope of the system of parallel chord. So if you take m to be the slope of this, take m to be the slope of the system of parallel chords, then in that case the equation of the diameter of an ellipse will be given by the formula y is equal to minus b square by a square m into x, or y is equal to m1 into x, denoted as equation 1, where m1 is equal to this one minus b square by a square m. Now I need to show that tangent at this point here will have the same slope as this one, minus b square by a square m. So let us, same slope as m. So now here, what is the equation of the tangent at this point x1, y1 to an ellipse? We have discussed it earlier. So it will be given by x1 by a square plus y1 by b square is equal to 1. So this is the equation of the tangent at px1 y1, which is one end of the diameter bisecting the system of parallel chords. Now, from this equation, you simplify, then you'll get y is equal to minus b square by a square x1 by y1 into x plus b square by y1. So on simplifying this one, expressed in the form y is equal to mx plus c. So the equation of the tangent of the ellipse at the point x1, y1 will now be given by y is equal to minus b square by a square x1 by y1 into x plus b square by y1. Now name this as equation 2. But we have from this equation, from 1 we have what is y is equal to m1x, where m1 is equal to minus b square by a square m. So now here from equation 4, from this equation 2, what is the slope of this tangent? The slope of tangent is given by, say, let me take it as m2 is equal to minus b square by a square x1 by y1. Now minus b square by a square x1 y1 represent the slope of the tangent. But what is this one? What is we have this one, y is equal to minus b square by a square m into x. So you can find out what is x from here. So you'll get from that equation 1, you'll get y by x is equal to m1. So since x1 y1 is a point which lies on this diameter, so in that case y1 by m1 also will be equal to m1. You just replace y by y1 and x by x1. Then in that case you'll get this one. Now it will be m2 is equal to minus b square by a square. What is x1 by y1? It will be m1. So it will be m1. Or m2 now is equal to minus b square. But what is m1? You can replace it by this one. It will be minus b square by a square will be there into m1. What is this m1 here? It is minus b square by a square m. Okay, let me write it here properly. So m2 is equal to minus, okay, I think there is mistake out here, x1 by y1 is equal to m1. But here I need to y1 by m1 is y1 by x1 is equal to m1. So it means that x1 by y1 is equal to 1 by m1. So here it will be not m1, here it will be 1 by m1. Replace the value of m1 now by minus b square by a square m. Then you will get this one, minus b square by a square into, now 1 by m1, it is minus b square by a square m. Minus b square can be cancelled, a square can be cancelled. Now this m will come to the numerator. It implies that m2 is equal to m. So now m2 represents the slope of this tangent at the point x1, y1. But finally we are able to show that m2 is equal to m, which is the slope of the system of parallel chord. Now since the slope of this tangent is same as the slope of the system of parallel chord, so it means that the tangent now at the one end of the diameter will be parallel to the system of parallel chord bisected by this diameter. Hope it is clear. You please go through again. If it is not clear, you please inform me.